Have you ever stopped to think about what's really happening inside your computer? I mean, it all feels like magic, right? But every single thing you do, even something as simple as pressing one key, kicks off this incredible chain reaction. So today, let's pull back that curtain and uncover the secret life of a single keystroke.
So think about it. You tap a key, and a letter just pops up on the screen. Seems pretty straightforward, yeah? But what's the actual journey that character takes from your finger to the display? What language is it speaking to the machine to make all of that happen in a split second?
Well, here's the secret. It's not magic at all. It's all about translation. The entire digital world is built on this constant process of converting information from a language we humans get into a language machines understand, and then right back again. We're going to follow one little character through this whole wild ride.
Okay, so our story starts with the very first and maybe the most important translation, turning a letter from our alphabet into a secret code that pretty much any computer on the planet can understand. To make this super clear, we're going to pick one character and follow it from start to finish. Our hero for this journey? The uppercase letter A. Now, when you press A on your keyboard, you might be surprised to learn the computer doesn't see a letter at all. It sees something completely different.
What it sees is a number, and it knows which number thanks to this kind of universal dictionary for computers called ASCII. Think of it like the Rosetta Stone of computing. It's a standard chart that gives a unique number to every single character you can type. Letters, numbers, punctuation, all of it. This just makes sure every computer agrees on what's what.
So for our letter A, the computer registers the decimal number 65. And just like that, that's our first translation. Your human letter has become a universal number. But we're not done yet, not even close, because computers don't really think in numbers like 65. They speak in even more basic language. So now, our next job is to translate that number, 65, into the actual native tongue of all digital electronics, a language that's made of pure electricity. And this, right here, gets to the physical heart of what a computer is. At its very core, a computer is just a gigantic collection of millions or billions of tiny switches that can either be on or off. That's it. High voltage or low voltage. There is no in-between. So how on earth do you represent the number 65 using only on and off? Well, that's where binary comes in. It is the perfect language for a system that only has two states. Instead of the 10 digits we use in our daily lives, binary only has two. 0, which represents an off state, and 1, which represents an on state. Any piece of information you can imagine can be represented by a sequence of these ones and zeros. So our number 65, which started as the letter A, now gets translated into this long string of ones and zeros. 0, 1, 0, 0, 0, 0, 1. This is what the computer's processor actually understands and works with, just a simple pattern of electrical signals being on or off. All right, so the computer is perfectly happy with its long strings of ones and zeros, but what about the poor humans, the programmers and engineers, who have to build and fix these machines? I mean, can you imagine trying to read pages and pages of binary code, like the string we just saw? You'd go crazy. It would be incredibly slow and you'd make a ton of mistakes. So obviously, people needed a better way, some kind of middle ground between our numbers and the machine's binary. And they found the perfect solution: hexadecimal. Hexadecimal, or just hex for short, is a base 16 system. It uses our normal digits 0 through 9, and then it just adds the letters A through F to represent the values 10 through 15. But its real magic trick is that it's an incredibly clean and simple shorthand for binary. So here's the deal. Binary is perfect for the machine's hardware, right? It maps one-to-one with those on-off electrical states. But it is a total nightmare for us. Hexadecimal, on the other hand, is super compact, way easier for a human to read, and, this is the important part, it translates to and from binary with almost zero effort. So how does that even work? How is it such a good shorthand? Let's check out the brilliantly simple connection between hex and binary that makes it all possible. Okay, here's the trick, and it's so clever. You just take any binary string and you chop it up into little groups of 4. So that first group, 1, 1, 1, 1, that just converts to the hex digit F. The second group, 1, 0, 1, 0, becomes A, and boom, that long, ugly binary string becomes the short and sweet FA. It really is that easy. And that, my friends, completes the entire journey. Let's just run it back one more time. The human presses the character A. The computer, using ASCII, sees that as the decimal number 65.
The processor then reads that number in its native tongue, binary, 01000001. And finally, a programmer looking at that exact spot in memory would see it represented as the clean, compact hexadecimal value 41. 4 different languages, all for one single keystroke.
So you might be thinking, okay, that's cool, but why does it matter? Well, because this whole process of translating between number systems isn't just for typing. It's happening absolutely everywhere, all the time, in everything your computer does.
This table really sums it up nicely. Each of these number systems has a very specific job to do. Decimal is for us, the humans. Binary is the raw language for the machine's circuits. And hexadecimal is that practical, convenient bridge that lets programmers talk to the machine. Each one is a critical tool for a different task. And once you know what to look for, you start seeing these codes everywhere. Ever seen a weird string of letters and numbers when your computer gives an error message about a memory location? That's a hex address. You know the color codes on websites like #FFF for pure white? That's hex. The basic instructions your processor runs, the data sent over the internet, it's all built on this foundation. So what feels like one single instant action to us is actually this lightning-fast sequence of translations between different languages. It's this elegant, multi-layered system that is the invisible bedrock of our entire digital world. Pretty amazing, right? So the next time you type a message or click on a color, just take a second to remember the incredible journey that signal is taking. It leaves you with a really cool question to think about. If something as simple as a keystroke is built on such a complex code, what other magic in your digital life is really just another clever translation waiting to be discovered?